Hello everyone, this DBT useful for data engineers. So it is for transformations. DBT specializes in transforming raw data into a structured format suitable for analysis and reporting. This involves tasks like data cleaning, aggregation, and joining disparate data sources. SQL-based DBT uses SQL, structured query language, as its primary language for defining transformations. This makes it accessible to data engineers and analysts familiar with SQL, eliminating the need to learn a new programming language or framework. Modularization and testing. With DBT, transformations are organized into modular SQL files called models. These models can be tested independently, promoting code modularity and ensuring the quality of transformations. Dependency management. DBT allows users to define dependencies between different transformation steps, ensuring that transformations are executed in the correct order. This helps prevent errors and maintain data consistency. Version control. Just like software code, DBT models can be version controlled using tools like Git. This enables teams to track changes, collaborate effectively, and revert to previous versions if needed. Documentation and data lineage. DBT automatically generates documentation and data lineage information based on the defined transformations. This helps users understand how data flows through the system, facilitates auditing, and ensures compliance with regulations. Overall, DBT simplifies and standardizes the process of building data pipelines and performing data transformations in data engineering projects. It's particularly popular in modern data stacks that leverage cloud data warehouse. Key components of DBT. First, start with models. DBT models are SQL queries that define transformations on your data. These models are written in SQL and are used to extract, transform, and load ETL data into your data warehouse. Models can depend on other models, allowing for easy reuse and modularization of your transformation logic. Sources. Sources in DBT represent the raw data in your data warehouse. They define the tables, views, or files that you'll be transforming in your models. Sources provide metadata about your data, such as column names and data types, which DBT uses to validate your transformations. Seeds. Seeds are small data sets that you load into your data warehouse to serve as the basis for your transformations. They are useful for testing and development purposes, or for loading reference data that doesn't change frequently. Snapshots. Snapshots allow you to track changes to your data over time by creating historical copies of your tables. You can define snapshot models, in dbt to capture incremental changes to your data and build historical reports or analyze trends. Tests. dbt allows you to write tests to validate the results of your transformations. Tests can check for things like data types, null values, or referential integrity to ensure the quality and correctness of your data. Documentation. Documentation in dbt is automatically generated from your models and provides context and explanations for your data transformations. It's crucial for understanding the purpose and behavior of your models and for collaborating with other team members. Hooks. Hooks are custom scripts that you can run before or after your models are executed. They are useful for tasks like loading data from external sources, triggering notifications, or performing cleanup operations. Packages. dbt packages are reusable collections of models, tests, and macros that encapsulate common data transformations or best practices. They allow you to easily share and reuse transformation logic across projects or within your organization.